Hey 30-2s, here we are in our final lesson of this unit. Today what we're going to do is we're going to solve. So we're going to be doing something very different than we have in the past few lessons. Well, what does that look like? Well, up until now, what we've been working with have been expressions. Today what we're going to work with is an equation. So what's the difference between an equation and an expression? Well, the difference is simply this. We have an equal sign. And as soon as we have an equal sign, now we're able to answer math's greatest question, right? What is x? We can finally answer that question. Okay, the steps are going to look fairly much the same as what we've been doing the last few lessons. And in fact, I think that this will be much easier than adding and subtracting. Now, the last thing I want to pay attention to here before we go on is this. We're going to have to pay special attention to our restrictions, and I'll show you why you want to star that. So let's solve these things. Okay, our steps are going to be pretty much the same. Step one is there anything I can factor? Well, in equation one or question one, no. Step two, are there any NPVs? In this one, no, because the denominators are 4, 3, and 2. Step three then, let's get a common denominator. Well, my common denominator is going to be 12. So what I'm going to do is I'm going to multiply every term, top and bottom, by 1 in a sneaky way to get that common denominator. And I'm going to write everything with that common denominator, just like that. Now, from here, my friends, there's definitely more than one way to solve this question. But what I'm going to say is this is an equation. If the left-hand side is equal to the right-hand side and the denominators are equal, therefore the numerators are equal. All I need to be working with here now are the numerators. Okay, that's how I like to approach the question. Other teachers like to say, okay, let's now multiply everything, both sides, by the common denominator, which would then divide out the 12s. So it's the exact same idea. So there's definitely more than one way to do this. Now all we got to do is solve. So add 20, divide by 9. And friends, there's my answer. Okay, that one was a bit easy because it didn't have any variables in the denominator. Okay, let's take a look at step 2, or question 2. Can I factor? No. Non-permissible values, well, right here, x can't equal 1/3. Okay, I'm going to put a box around that so I remember it when I'm solving. That's a big deal. Okay, I'm going to multiply both sides to get my common denominator, just like that. Okay, again, I like to show that myself. So it's going to be just that. It's not much different than the line above, but I am just going to write it down just to make it nice and clear for you. And again, if the left-hand side is equal to the right-hand side and the denominators are equal, therefore the numerators are equal. That's the same as saying I'm going to multiply everything by the common denominator. Now all we need to do is distribute in and solve. Now the interesting thing is, this is where we see a lot of mistakes, not the grade 12 part, but this part here, which is more like grade 9, just isolating for x. So slow down here. So I'm going to bring all my x's to the left side. So I'm going to subtract 9x. I'm going to add 8. That's 5. Bingo. Okay, yeah, that's not too bad. Let's do 2 more. Okay, now we're starting to look a little beefier, right? These are starting to look a little more intense. Okay, number 3 and number 4. Number 3, step 1, factor. Yes, I see something that I can factor. This one has a GCF of x. Then I say to myself, my non-permissible values. So I'm just going to write them again up here. X can't equal 0, x can't equal 3. I'm going to put a box around them so my teacher sees them and so that I remember what they were. Okay, now I'm going to multiply each term by what I need to get that common denominator. So these both need an x and an x minus 3 respectively. Now that I've got my common denominator, I'm going to say, therefore, the numerators are equal to each other. Okay, I also noticed that this is a subtraction. And if you remember back to the last lesson, adding and subtracting, I have to be careful about that negative distribution. So quite often what I would see here is minus 15. But I need you to know a negative times a negative is a positive 15. Okay, and again, my warning is just slow down here when you're solving these. So now I'm going to say subtract the 15. So I've got x is equal to 3, right? And I'll see a lot of, boom, there's my answer. But whoa, wait a minute. What is this up here? It says x can't be 3. But down here, my answer says x is 3. So what we're going to do is we're going to cross this off, and we're going to say that is an inadmissible answer. We're going to call it extraneous. Okay, so I need you to cross that off and write the word extraneous. So what do we write as our answer then? Well, there is no answer. There is no solution. Okay, so you can see why now I'm saying writing down your non-permissible values at the beginning is so important. Guess what I'm guaranteeing is going to happen to you on a major test? An extraneous root, it's called. Okay, let's try another one. So last question. This one says, okay, same thing, step one, factor. So I see a little bit of factoring. I see that difference of squares, which by now you are getting very good at, aren't you? Okay. Now again, I'm going to multiply every term by what it needs. So this one needs an x minus 3. This one needs an x plus 3 and x plus 3. Okay, now that the denominators are equal, that means the numerators are equal. Okay, again, that's the same as saying multiplying everything by common denominator. And here we go. Let's start distributing. 2x squared minus 6x plus x squared plus 3x is equal to 18. Collect some like terms. 3x squared minus 3x is equal to 18. Okay, what I do notice here is I can divide everything by 3, so that's nice. Now, x squared minus x is equal to 6. A wrong move that I would see some students make when they're trying to solve this is they say, okay, let's factor this. And then say, oh, okay, x is equal to 6 or x minus 1 is equal to 6. I'll see that. Okay, I don't want to see that. They're almost right, like I can see what they're trying to do, but it's not what I want them to do. What I want them to do is this. It's a trinomial. So subtract over the 6, make one side equal to 0, and now factor this. Okay? This only works if one side's equal to 0. It's the zero product property. So then I say x is equal to 3, x is equal to negative 2, and I'm done the question, right? No, not right. Again, notice what I missed. I never stated my non-permissible values. Should be x can't equal positive negative 3. So you see, if I hadn't said that, I wouldn't have thought to cross that one off and say extraneous. So our only solution is x is equal to negative 2. So I can't stress enough how important it is to find those non-permissible values, box them for yourself and for your teacher, and then check them at the end. Now, the only other thing I haven't mentioned here is it's really easy to check our work. All we do to check our work is take whatever our solution is and sub it back into the original equation. And if the left-hand side equals to the right-hand side, numerically, then you've done this question correct. Okay, there is solving rational equations.